this particular bell work. So angle A. Angle A must be this one. It's 110. 110, is that right, acute, or obtuse? It's obtuse. It's obtuse because it's bigger than 90 degrees. Then we have angle B being 60. 60 is less than 90, so that's going to be acute. C, we should have put obtuse again because it's 100. And D is exactly 90 degrees, which means it's not acute, it's not right. I'm sorry, it is right. It's not acute, it's not obtuse, it is right. Does anyone remember the one angle I didn't put up there? Straight. Keep that one straight in your head because that one gets forgotten about all the time. If I draw a straight line, it's a straight angle. What would the measure of a straight angle be? If a right angle is 90, what would it be if I had a straight line? It'd be 180 degrees. You need to know that as well. All right, the next one is deceivingly hard. That's why I was putting it on a bell work, because a lot of times it shows up on the test and people freak out about it. It says draw a midpoint which includes segments MN and NP. So we need a midpoint that includes both of those segments. Now, what I'm thinking about first of all is I'm like, okay, they give me two segments. You see how it's MN and then N repeats itself and it goes NP? That must mean I'm pasting two segments together at N. I'm taking N and pasting two segments together. We can't have two segments that both have N on it. In the same picture, N must be the same point, so that must be the glue that holds them together. So what we're talking about is a segment where we glue together two segments right at the midpoint, and that will be M, N, and NP. Now, you cannot, I think I saw some of us had it. We had that line where we had an M, N, and P. Now, remember, midpoint doesn't mean that I guessed at the middle. To be a midpoint, it must have tick marks on it. So midpoint must have those two tick marks on it for it to be correct. So if this was on a test and I said draw the midpoint N on this segment and you didn't have those tick marks, it's not a midpoint and we'll lose some points. Because to be a midpoint, it must have tick marks. Just like remember yesterday we had that angle bisector, we had to put those arcs on it to say that we have congruent angles. Anytime we cut something in half, we need to indicate it's actually in half. Okay? All right, then let's quickly go over homework questions. I did have someone brought to my attention that we should do 3 and 31, so I'm going to do those first, and then we'll do which other ones you have questions on. Let me go back. So number 3 says, if EFH, so it's always a good idea to understand what they're talking about. So EFH is this one. In this order, when they give you them in order, just draw it on your hand, or you can even use colored pencils. This would be EFH in order. That one's supposed to be 5x plus 1. So we'll say that's 5x plus 1. Then they give me HFG. HFG is the other small angle. HFG is going to be 62 degrees. And then finally they tell you the whole thing, EFG, the whole thing. So what I do is I draw a little arrow like this and say that is 18x plus 11. Now, when you have an angle glued to another angle, that is an angle plus another angle equals the total angle. So angle plus angle equals total angle. So we have EFH. That is 5x plus 1. Plus the other angle that's glued to it. That is that 62 degree one. Plus 62 degrees is going to equal, now that will be our total 18x plus 11. You never know where the number is going to go, or maybe they'll all have x's in it. You just have to remember it's angle plus angle equals our total angle. Now we just have to go ahead and solve this. So the first thing I would do is I'd simplify both sides. We really don't need the degrees. A lot of times I'd kick them out so we don't get confused. That 62 actually goes with that 1. So I will have 5x plus 63 equals 18x plus 11. Now I'm going to make sure all the x's are on the same side. I can either subtract 18, which will give me a negative, or I can subtract 5. I usually just I'll subtract the smaller one, so I have a positive. So I'm going to go ahead and I'm going to subtract 5x from both sides. That will cancel out that 5x and move it over here. That's going to now give me 63 equals 13x plus 11. Don't worry about the 13x yet. We always do our addition and subtraction first. So I'm going to move the 11 over here. You will not do anything with the 13 until we have all the x's by itself. So my next step is actually subtracting 11 from both sides to get rid of that 11. Subtract 11 over here. I'm going to now have 52 equals 13x. Notice now I just have x's and numbers on the other side. Your next step is going to be division. So your last step is division. So my last step is actually dividing that 13. Be careful. This is what I see all the time. Can we all look at the board real quick? And if you don't make this mistake, awesome job. I'll see people cross this entire thing out and they lose all their x's. Remember, the whole point of dividing by 13 is to turn that 13 over 13 and 1 to leave you with 1x. Now we divide the other side by 13. 52 divided by 13 is 4. We have 4 equals x. We come over here and we fill that x in here. I'm sorry, not x. X equals 4. But we aren't done on this problem. The first one said, I need to solve for x. This one said, I need to solve for x and I need to find these missing angles. So we have to go back up and see what those angles mean. So I look back up at E, F, H. Do you see that 5x plus 1 I wrote there? Now I know what x equals. X equals 4. So we can go ahead and say, well, now I can find the measure of EHF. Let me cross that out. So I have measure of angle EFH equals 5x plus 1. But we know our x is 4. So instead of 5x plus 1, we're going to have 5 times 4 plus 1. I'm going to replace that x with that 4. 5 times 4 is 20, plus 1 is 21. So we're going to have 21 degrees. EFG is 18x plus 11. I will put the 4 in for the x. So I'll have 18 times 4 plus 11. I'll let you do that if you don't have that one done. I'll give you that one step. Any questions on number 3 of how I did any of that? That one's important. That one's just important, that you understand that something plus something equals the whole thing. And then the other question I had was 31, and then we'll go over your guys' questions. As many as we can do. We might not have all the time in the world. So it says, write 2 other names for angle CBD. So if we look at CBD, CBD is this angle here. I'm sorry, CBD is this angle here. I pointed to the wrong one. One method is pretty easy. It is to flip the 2 end letters. So the first one I would do is angle DBC. As long as this middle one stays your vertex, you're fine naming it. The big mistake you're going to do on this one is you're going to call it angle B. You cannot call it angle B because there's actually 3 angle Bs. There's a big angle B, there's this red angle B, and then there's this other angle B. The only other way you could name it, and this doesn't happen all the time, is, do you see that number right there? That 2? That is a way to name an angle if there's a number there. If there's a number there, then we're not worried about points. It's kind of like, remember on a line, you could put a lowercase letter, and you could name it like line L. A plane could have something in the corner, you can call it like plane X. We can call this one angle 2 because it's kind of named for us. We know which one's angle 2, so if I say look at angle 2, you should be looking at that red one. Okay? Now let's open the floor to some other questions. Yeah. Number 10. Number 10 says if CDE is a straight angle, so they're just basically telling you this is a straight line. DE bisects GDH. Let's stop right there. So let's highlight GDH. GDH is this guy right here. This is where it's important that you know how to write the information on the drawing. If DE bisects this angle, it creates two congruent angles. So I'm going to go ahead and because it bisects, both of those are the same. That's the definition of bisect. So it says DE cuts this angle in half, so it creates two congruent angles. So if this one's 40 degrees, this one's also 40 degrees. I'm guessing that's going to be important later on. Then it says measure of angle GDE. GDE is 8x minus 1. So let's go ahead and put 8x minus 1 here. Then it says EDH is 6x plus 15. And then it says that measure CDF. So we have CDF right here is 43 degrees. Our job is to find all of those different bits of information. All right, so we did 10, realizing all that stuff. 9 says QS bisects. Once again, you need to know what that word bisect means. It means creating two congruent angles. So if QS bisects PQT, so highlighting PQT, bisect means it creates two congruent angles. So that means PQS and SQT are equal. Well, they tell us that SQT, they tell us that an entire thing, SQT, is 8x minus 25. So this SQT is 8x minus 25. They tell you that PQT, that will be our entire thing here, PQT, is 9x plus 34. And then it says SQR. SQR is going to be 112. We're supposed to find each of those bits of information. So this right here, kind of running out of room. Let's change our color real quick. So this right here is 112. So we have two congruent angles. We have one of the angles is 8x minus 25, SQT, and then we have the entire PQT is 9x plus 34. So what we need to realize is we need to come up with an equation to solve. Well, 8x minus 25 does not equal 9x plus 34 because 9x plus 34 is this whole thing. But here's something you can always do. See how this is 8x minus 25? I could then say that this one's also. So this is what I'm going to add to my drawing. I'm going to say this one is also 8x minus 25 because they're both the exact same. Now we can do angle plus angle equals big angle. Once again, angle plus angle equals big angle. So I'm going to take that 8x minus 25. I'm going to add it to the other 8x minus 25. And that's just going to equal the entire PQT, which is 9x plus 34. And with that, we'll solve for x. We'll plug that in these. We'll get these missing angles. And knowing that this is 112, we're going to do subtraction. So once I find this angle, I can subtract it from 112, and I'll get that angle. That's kind of as far as I want to go. Is that a good start for you? Yeah. If you get stuck again, just let me know, and we can work on it later. Other questions? Okay. I'm not going to pause too long because we do have a quiz at the end of class, and I want to make sure we have plenty of time for it. That's our goal, that we can do successful on that quiz. So we're going to go through a rather short lesson. just kicking off some more words that we need to know for the test. Remember, this is our last lesson. Our test is next Thursday, but this is our last lesson. So these are our last of our big words. And my goal is we'll have a review on Monday. I'll hand out to you guys. Maybe I'll hand out like a list of all the words that we know too, just so you can like rehash those. All right, so complementary angles. They like to complement each other. No, not really. Complementary angles are angles whose measures add up to, now this is the only rule for complementary angles, they have to add up to 90 degrees. That's it. I just need two angles that add up to 90 degrees. Listen to that rule. I just need two angles that add up to 90 degrees. So, complements or complementary angles can either be adjacent, which means they're pasted together, or they can be way away from each other. So I could have something like an angle here. Let's say that's 30 degrees. And I could have an angle way over here. Maybe that's a little big for 30 degrees, but that's okay. If this is 30 degrees, what would this have to be for them to be complements? I heard whispers. What would it have to be? It would have to be 60 degrees. It would have to be 60 degrees, and then we'd have a complement. So look how far away they are. They're still complements because they are add up to 90. There's just one rule. To be a complement, you must have two angles that add up to 90 degrees. That's it. So complement, 90 degrees. Supplement, on the other hand, supplement and complements go together. They're the ones that we can confuse with each other. What I like to keep track of it is like the word supple. If you think of a supple apple, it's a big, juicy apple. So supple means bigger. Complement's 90. Supplement is going to be 180 degrees. So if I have two angles that add up to 90, I have a complement. If I have two angles that add up to 180 degrees, we have a supplement. So we have 180 degrees. Once again, there's no requirement on these. I just need two angles that add up to 180 degrees. That's it. And you have a supplementary angle. So if you look here, we have 50 and 130. That equals 180 degrees. Then we could talk about something like this. There's going to be times where I don't know the complete measures of things. Well, if this is x, then its supplement must be 180 minus x. In other words, if this is 50, this must be 180 minus 50, and it is. 180 minus 50 is 130. And we'll talk about that in a second. You're going to need that kind of information on the homework. So, example 1. We are supposed to name the complement and supplement of each of these angles, reminding yourself what those mean. So I need a complement and a supplement of each of these. I don't want you to shout anything out. I just want us to think about this. I need a complement for 10 degrees, and I need a supplement for 10 degrees. Write down what you think the answer should be. What is the complement of a 10-degree angle, and what is the supplement of that angle? Put something down. I shouldn't see blank stuff. We should put a number down. Who cares if we're wrong? We can erase it. Education is all about making mistakes and learning from our mistakes. Oh, we're not drawing pictures. Oh, we're just trying to find a complement and a supplement of this. So I want actual numbers. Oh, you did? Okay, sorry. You just wrote them small, right? Oh, I got you. Okay, good. All right, did anyone get the complement of it? Raise your hand if you think you have the complement of it. I see a lot of right answers. Kennedy? 80 is correct. 100% correct. 80 is 100% correct because what's 80 plus 10? 90. That's a complement. What would our supplement be then? Yeah, Matthew. It would be 170 because 170 plus 10 is 180. Okay, now my measure of angle A is now 75. I need a complement and I need a supplement. Can someone raise your hand and tell me what the complement would be of a 75-degree angle? Someone new. Raise your hand. Yeah. It would be 15. I 100% agree with 15 because 15 plus 75 is our 90. Who can give me a supplement? Someone new. What would the supplement to a 75-degree angle be? Yeah, what did you get? 105 is 100% correct. All right, I don't think complements and supplements are really hard unless you don't study it and you get to the test and you've never seen those words before. I know you see them now and you're like, I'm not going to study them. Just study the words. Study the words. Now, here's the problem with the last one. Do we actually know the number value of measure of angle A? No. So this one's just a little bit tougher. So I'm not going to have a number for my complement. I'm also not going to just have a number for my supplement. I actually have some people that already have this down and it looks correct. Does someone want to help me out how I could describe the complement? I can't give a number, but I can describe how to find it. What would my complement? You got this one? It'd be 90 minus y. Perfect. The complement would just be 90 minus y. That's as far as I can go. I can describe how to find it. I can't give it to you, but I can describe how to find it. That if you told me this was 10, if all of a sudden you're like, y is 10, that means your complement is 90 minus 10, which is 80. If we find out our y is 75, our complement is 90 minus 75, so our complement would be 15. So what would the change be if I want to describe the supplement of it? It's going to be 180 minus y. Yeah. So I don't have to give you a number, but you can still describe how to find that complement in that supplement. All right, the next word we're going to talk about is linear pair postulate. Linear pair postulate. You just need to know the word linear pair. Linear pair and supplementary angles are going to be constantly confused with each other. Now pay attention to why linear pairs are different than supplementary angles. Linear pairs are two angles that are adjacent. In other words, they're glued together. So they have to be glued together. That's what adjacent means. Adjacent means glued together and form a supplement. Or 180 degrees. So, supplementary pair. If I say something supplementary, they can be miles apart, as long as they add up to 180. To be a linear pair, they must be supplementary and pasted together. That's why they call a linear pair, because they're going to make a straight line. So a linear pair, if I have to draw a linear pair, I'm going to start with just drawing a straight line. And I'm going to draw an angle like that. That is a linear pair. It is a pair of angles that make a line. And a line is 180 degrees, so a linear pair must be a supplement. Sometimes I don't even think about supplementary, I just think about a linear pair makes a straight line. Angles that make a straight line. That is honestly how I remember it. Linear means line. Line means two angles that make a straight line. So a linear pair must be pasted together. Supplementary can be miles apart. We're clear on the difference between those two things? For now, we'll see next Friday, right? Really, the last thing we're going to cover today is vertical angles. Vertical angles are probably without a doubt one of the more hidden things in pictures that people forget. But once you start picking up on it, it can make a lot of problems a lot easier. Vertical angles. Now, if you remember, on the very first day you walked into this classroom, I had vertical angles on the board. And no class 100% got what vertical angles are. So let's describe what vertical, and that's why I said it was a really important thing. Maybe we can learn it and we'll crush it from now on. Vertical angles are the angles that are, basically they're just the ones that are across from each other. They are angles that are directly across from each other. And the big thing is going to be that they are, in fact, congruent. I'm just make sure I didn't miss anything along the way. We're good there. We're good there. Okay, so they are the angles that are across from each other. Oh, we need an H in each other. So they are angles that are across from each other when two lines intersect. So you need to be able to picture two lines intersecting, and there must be angles across from each other. So we're looking at these right here. Your vertical angles are going to be the ones that are directly across from each other. If you are a vertical angle, you are congruent to each other. Vertical angles are congruent to each other. So do you see how A and B are across from each other? That means those two angles are congruent to each other. So we can do something like angle A is congruent to angle B because they are vertical angles. Do C and D look like they're across from each other? Yeah, so C and D would be equal to each other. So we could say something like angle C is congruent to angle D because they are vertical angles. So if you're directly across from yourself, another angle, you are a vertical angle and you're congruent. You're a vertical angle and you're congruent. I'm going to make a little box here and put something that's not vertical angles. These are not vertical angles that people often think are. Now notice how I kind of shortcut stuff. If I want to use the word angles without writing angles, I just put an angle, apostrophe S. That means angles, rather than having to write the whole thing out. These are not vertical angles. If I draw a straight line, and I draw an offshoot here, and I draw an offshoot here, and I look at 1 and 2. Don't 1 and 2 kind of look like they're across from each other? So they meet that requirement that they're across from each other. But what in the definition makes those not vertical angles? What was that? It's not two lines intersecting. Yeah, that's actually 3 lines. I have 3 lines there. So if I had to draw this, with my pencil, I would have to draw this line, I would have to draw this line, and I would have to draw this line. Those are 3 different lines. In order for them to be vertical angles, they must just be 2 lines. They make an X. You're looking for something that makes an X. This is a K, kind of like a sideways K if you turn your head. That is not an X, so there's no vertical angles. You need to look out for an X for those. All right? Those are vertical angles. Those are huge in this class. Vertical angles are huge in this class. They're going to keep popping up over and over. So will supplementary and complementary, but people are generally good about supplementary and complementary. You just forget which one's 180 and 90. That's a big thing. But vertical angles are big to start picking out. We're going to skip the postulates and theorems. That's really chapter 2. We'll just talk about them. You don't need to write them down. But a postulate is just basically our building blocks. Remember how we had like points and lines and planes that we just took? We said that those are true. Postulates are going to be backbones of the geometric world. They're going to be things that we just accept are true. Theorems, on the other hand, are going to be things that we're going to prove are true. So postulates we just accept are true, and theorems we can use those postulates to actually prove that these theorems are true. We have something called the vertical angle theorem. Once again, I'm going to skip this because we do have a quiz today. But this is going to be chapter 2, where we're actually going to be able to prove that vertical angles are, in fact, congruent. But I want to skip to this example 2 real quick. Example 2 is the power of vertical angles. I need to solve for x and y, which means I need equations. Does anyone see anything we could write, an equation, based upon the drawing that could help me solve for either x or y? Anyone have a guess that we can write? I see some people are writing. It'd be nice if you gave us a hint. I said I'm just looking for an equation. How do I solve for x or y? I know I need an equation. Do we see vertical angles anywhere on there? Do we see an x? Yeah, so we have vertical angles. Vertical angles means opposite ones are in fact congruent. So if I look here, we would have these two angles are congruent. So we can set up an equation based upon congruency. If two things are congruent, they're equal to each other. So we can go ahead and write 7y minus 12 equals 6y plus 8. And then we just have to solve for y. It just says we're supposed to solve for y and x. This will give us our y. So what I'll do is I'll go ahead and I'll subtract 6y from both sides. Uh, 7y minus 6y is just 1y. So we have y minus 12 equals 8. I'm going to add 12 to both sides. And now I'm going to have y equals 20. So I set up my equation. I solve for that missing variable. What equation can I write to solve for x then, using that as a template? Were you raising your hand or you just... No? Okay. What would our other equation be? I need to solve for x. What would our other equation be? Chris, kind of, maybe?
6x minus 26.
Yep. Equals 4x. Perfect. Because they're vertical angles. They're across from each other. We just need to understand that if you're across from each other, I'm going to put 2 arcs on there saying that those are equal to each other. When they're across from each other, they're equal, and I can use an equal sign. So Chris said we're going to do 6x minus 26 equals 4x. Now note, you could have did 4x equals that. Doesn't matter what order you put it in as long as you have the equal sign in the right place. All right, I'm going to go ahead and move the 4x to the other side. When I move the 4x to the other side, I will now have a positive 2x minus 26, noting that 4x minus 4x is actually 0. I actually put a 0 on that side. Now I'm going to go ahead and I'm going to add that 26 to both sides. That's going to give me 2x equals 26. And then we'll have x equals 13. But you need to know vertical angles in order to solve those. Questions? Okay. We have just a couple classroom activities, and then we'll move on to our quiz. If we have any questions about that, we can answer that really quick. But our classroom activity is name 2 right angles. Well, I'm going to take the hard one. LMP. LMP is definitely a right angle because we got that 90-degree angle right there. So I'm going to start with name 2 right angles. I'm going to name one of them, and that is angle LMP. What's another right angle? What was that? Say it aloud. LQP? I think LQP, so if I do it in that order, I'll do it in that exact same order. So L, you said QP? I think that one's 80 degrees though, right? So when I colored it in, that would give me 80 degrees. So that's not going to quite work. We're getting there. We're taking shots. Delilah? QLM. QLM. Did I highlight the right angle? I think you know it. You just described it wrong because QLM would be 100 degrees, right? Are you raising your hand? Nope, not doing anything. Chris? QPM. Let's highlight it just in the order you said it. QPM. What's 50 plus 40? 90? I think that's the one you wanted. We just got to be careful how we name these. QPM is going to be correct on that one. So we can use QPM. And angle QPM. Just a note, if I didn't point this out, this just means and. That's just an and symbol. This and that. Name two adjacent complementary angles. Adjacent means glued together. What does complementary mean again? What does complementary mean again, Matthew? The two angles when added equal 90 degrees. Do we have two things that add to 90 degrees? Yeah, we got this 40 and 50. We just got to be careful naming them. They're not asking what's the big angle that makes 90 degrees. They're asking for the individual angles that when added equal 90 degrees. So it's not going to be QPM. Instead, we need to recognize the fact that, well, I have one angle that's 40 degrees. I need to name the angle that makes 40 degrees. And then I need to name the angle that makes 50 degrees. Now remember, when you are naming an angle, you're just describing how to draw it. So if I want to draw 40, I would go QPL. So my first angle could be QPL. And my second angle will be that 50 degree one, which will be LPM. LPM. What are we done at 55? That gives us 35. We're just going to, I'm going to quickly roll through this activity, if you will, with me. Do you see this 40 degree angle right here? If I go straight across, we have a vertical angle, so that one is also 40 degrees. So when filling this out, my job is to actually fill out this whole thing, then we can go back and answer the question. So if that's 40, this is also 40 degrees. If this one's 60, that makes this one right here 60 degrees because those are vertical angles as well. This is where people get stuck though, but let's get unstuck real quick. We always need to picture straight lines when we're solving problems like this, realizing that this is 180 degrees. If this whole thing is 180 degrees, and I'm only missing one chunk of it, we're just going to subtract the other two, and that's going to give us our value. Yeah. It would be, it'd be 80 degrees. And then we go straight across because I have another vertical angle, and that would be 80 degrees as well. And now we have numbers for everything, so we could go over here and name all of those. But I'm going to go ahead and skip that so we can get into our quiz, so we can have plenty of time for our quiz, okay?